All right, so good evening everyone. Welcome to the class and welcome to BYJU'S exam prep. Very good evening everyone. Let's get continued with our series on the questions from the very well-known book of Signal and System, one of the best book. Okay, if you talk about the questions especially, okay, in fact the concepts also, the open hem, and today we are on to the chapter number 3. As I've told you, we'll be discussing all chapters and important problems from this. Important unsolved problems, because solved problems everybody can see the solution, but unsolved problems, especially those which are matching, which are relevant with the GATE and engineering services preparation. Those we'll try to focus more and more, right? Those will be focusing more. Very good evening everyone. So come on. Yes, everybody. Okay, so let everyone join quickly, and by the time let's get started a little bit. Okay, so Fourier series, continuous time Fourier series to be discussed. Good evening Kumar, good evening Harihar. Okay, and this is a brief intro about me, that's all. Okay, so guys, like the other chapters, like the other classes, you will get the PDF of this session also in my Telegram group. Okay, so you can be connected in my Telegram group, and for other important updates about my classes, updates about upcoming exams, notifications about PSUs, doubt discussions, and several other things, you can be there in the Telegram group. Good evening Bhanu. Okay guys, so 15th October, that is just Sunday, 2 days later. The BYJU'S exam prep brings you the national scholarship test for the GATE examination. If you want to enroll into the complete courses, the comprehensive courses of BYJU'S exam prep, the crash course also available, the full long-term courses available, multiple courses available. As per your need, you can choose your course, and you can get as much as up to 90% scholarship on the fee structure of that courses by appearing in this national scholarship test. So do not miss the chance. This Sunday from 9 AM to 9 PM you can appear at any time. And also guys, what is the right time to prepare for GATE 2025 in case you are targeting 2025? What is the right time to prepare? Dheeraj Sardana sir, all your favorite, my favorite, is going to bring you a free live interactive workshop again on the BYJU'S exam prep app. 18th October, the Wednesday, 18th October at 7:30 PM. Again on the BYJU'S exam prep app. Chalo guys, so as you know, in this session I told you will be specifically directly taking the screenshots, and so that you also know what question number it is. So this is the chapter number 3, and we are on to the problem 3.21. We are into the problem 3.21. Just a moment. Ji, chaliye. So let's get moving ahead with the problem 3.21. A continuous time periodic signal xt is real valued and has fundamental period t equal to 8. The non-zero Fourier series coefficients are given as a1 equal to a star minus 1 equal to j, a5 equal to a minus 5 equal to the 2. Express xt in the form, summation k equal to 0 to infinity ak cos omega kt plus phi k. Now, let's express this in the form. Now, if you want to talk about GATE, they can convert this into NAT or MCQ question by asking what is the value of this capital A2, what is the value of capital A1, yeah, what is the value of this omega k for k equal to 1, anything they can ask, so let's try to solve it up. Now, of course, if you talk about, an important point here, they have mentioned real valued signal. It is a real valued signal and it has a time period 8. It has a time period that is equal to the 8. So if you want to talk about the continuous time Fourier series representation, it has the exponential form, and it has the trigonometric form as well. So if you want to talk about the exponential form, I can write down any signal as summation ak या ck, depends on different books, different terminology, cos k, exponential form की बात कर रहे हैं, summation ak e raised to the power jk omega naught t, where omega naught is the fundamental frequency of the signal, which is of course 2 pi by t. Which is of course 2 pi by t, and in general the signal can have multiple elements, from minus infinity to the infinity. Similarly, a quick review about real signals. So especially if it is real signals, Okay, for real signals, the exponential form is applicable whether it is real signal or complex signal. But especially if you have a real signal, you can also express that Fourier series in the trigonometric form. Into the trigonometric form, and that is given by xt is given by a naught plus summation for positive value of k, that is k equal to 1 to infinity, ak cos k omega naught t plus bk sin k omega naught t. Okay, just a quick review of the formula. Okay, again I have been telling you since the chapter 1 class itself that since we are solving the questions of a standard book, open him. So when do you go to the questions? Of course, when your theory and fundamental parts are done. Okay, so again I will assume that you are done basically with Fourier series, at least you know the basic fundamentals. Okay, then you can solve the question. Okay, then you can solve the questions. Okay. Now, what is the relation between these Fourier series coefficients? Okay, now one way to convert into the trigonometric form. So they have given the a, that is when they say Fourier series coefficient, normally you will take it as the exponential Fourier series coefficient. From that exponential Fourier series coefficient, I need trigonometric form. Okay, one way is expanding e power j theta. Okay, cos theta plus j sin theta, using that identity. Another way could be you can directly remember, that is also very important, you can directly remember the relation between these coefficients. Okay, now what is the general formula for ak? What is the general formula for ak? It is given by ak 1 upon t, the Fourier series coefficients. Okay, the exponential Fourier series coefficients, and that is given by 1 upon t integral over one time period xt e raised to the power minus jk omega naught t dt. I will give you a shortcut for this also. Okay, very soon I will give you a shortcut for this. Okay, I'll give you a shortcut for this, but slightly later. थोड़ा सा wait करेंगे. Okay, in this class only I'll tell you. Okay, yes, interesting problems coming up, Ghosh. Okay, so this is what is the formula to calculate ak. Now, if I want to talk about the trigonometric Fourier series coefficients, okay, now out of this dear, whether you say k equal to 0, agar k ko 0 rakha, a naught, and that will also be equal to actually the capital A naught, they are both known as what? They are both known as the DC component. Okay, they are both known as the DC component. Why? Because if you put k equal to 0, you will get the 0 frequency. In general, the frequency is k omega naught. For k equal to 0, you get the 0 frequency term. That is known as the DC component. Okay, so now dear, what is the formula for this a naught? That is given by 1 upon t integral over one time period xt dt. Integral over one time period xt dt. That is also known as the average value of a signal in one time period. Average value of a signal in one time period. ठीक है, ये ध्यान रखना. अच्छा, whenever I am telling integral over one time period, what is that one time period? You can take integration 0 से t. There is also confusion in the students what to take the limit of integration. It can be 0 to t, or you can also take it as minus t by 2 से plus t by 2. ठीक है. अच्छा जी, what is the relation between the Fourier series coefficients? What is the relation between the Fourier series coefficient ak, which is known as the coefficient of cosines, is given by ak, that is small ak, exponential Fourier series terms, ak plus a minus k. Okay, it is actually ak plus ak star. Okay, ak plus ak star, but that is also equal to ak plus a minus k. Okay, and bk is given by the formula j into ak minus ak star, or once again it is j ak minus a minus k. This is the relation between the trigonometric Fourier series coefficients. Good evening, dreamer. अब ध्यान देना यहाँ पे. Okay, real signals. Okay, ak star equal to a minus k. What is this? Very, very important property. Every real signal, okay, the Fourier series coefficients are conjugate symmetric. Okay, the Fourier series coefficients will be conjugate symmetry. That is, the Fourier series coefficient for negative value of k, a minus k, is obtained by taking the conjugate of the Fourier series coefficient for positive value. A minus k equal to the ak star. A minus k equal to the ak star. Okay, that is what it is. Okay, so now what is given to you is a1 is equal to a minus 1 star, that is equal to j. Okay, and a5 equal to a minus 5 is equal to the 2. Okay, chalo, so let's come here. Okay, let us come here. So dear, from this information, I have a1 is equal to j. Okay, then what is a minus 1? Then what is a minus 1? These two will always be equal, as I told you, conjugate symmetry, but a minus 1 conjugate is j. So what is a minus 1? See, a minus 1 conjugate is j. Okay, so what is a minus 1? Okay, that will be j conjugate. And what is j conjugate? Minus j. x plus jy conjugate is x minus jy. Okay, ये हो गया एक तो, ठीक है. Now next point. Okay, so from here what I can obtain is the value of the a1. The value of what? The value of a1. Okay, what should be the value of a1? Come on, what should be the value for a1? Okay, what should be the value for a1? As I told you, addition of these two. Okay, addition of, as I told you, it is a1 plus a minus 1. Okay, a1 plus a minus 1. चलो, okay, वहीं पे करते हैं. And then you are given the next value, a5 is 2 and a minus 5, that is also 2. Okay, ये केवल डेटा लिख लिया. So now let us use this formula. So what should be the value for a1? Okay, let me add up another slide here. Okay, right. What should be the formula for a1? As I told you, a1 plus a minus 1. One is j, another one is minus j, so they cancel and a1 is equal to 0. Okay, similarly, what should be b1? The formula for b1 should be what? J into a1 minus a minus 1. Okay, so that should be equal to j into how much? a1 is j minus j. So there 2j, so this is equal to 2j square. Okay, what is j square? Is minus 1. J square is minus 1, so the answer is minus 2. Okay, similarly, let us find the a5 and b5 also. What should be the value for a5? What should be the value for a5? Okay, a5 is a5 plus a minus 5. Okay, a5 plus a minus 5. But what is a5 and a minus 5? Both are equal to 2. Okay, both are equal to 2. Similarly, what will be the b5? Okay, it is given by j a5 minus of a minus 5, and that is equal to j into 2 minus 2. That should be equal to the 0. That should be equal to the 0. Okay. Okay. Chalo. In the Fourier series chapter only, Dodge King. Okay, this is equal to j into 2 minus 2. Okay, so a5 is 4 and b5 is equal to 0. Okay, so now, thank you Subhash. Love from India as well. So, if you want to write down the trigonometric Fourier series now, xt should be written as how much? It should be written as a0, okay, plus summation k equal to 1 to infinity ak cos k omega naught t plus bk sin k omega naught t. Okay, that is what is required. But ध्यान देना, okay, ak is only non-zero. There is only one non-zero. a1 to 0 hai. Okay, only a5 will exist. So with respect to a, take k equal to 5. With respect to b, with respect to the bk, ठीक है. अब देखो, b1 is non-zero. Take the b1, okay, and b5 will be 0. b5 will be 0. This is equal to a0 and a0 is 0 because question में clearly बोला है, okay, these are the only non-zero Fourier series coefficient. Rest all are 0. Rest all are 0, including a0. Rest all are 0. Okay, so what is my xt now? What is my xt now? Okay, this will be ak. Okay, what is the a5? What is the a5? That is equal to 4 cos k का value रखा हमने 5. Okay, तो 5 omega naught t. Okay, plus, okay, for b it should be only k equal to 1 applicable. Okay, that will be b1, and what is the value of b1? That is the minus 2. Okay, that is the minus 2 into sine omega naught t. K ka value 1. Okay, now what is the value of omega naught actually? That is 2 pi by t. Time period of the signal mentioned is 8. 2 pi by 8, that is equal to pi by 4. So what is the value of xt? That is actually turning out to be 4 cos 5 omega naught t. So that becomes 5 pi by 4 into t. Okay, minus 2 sin omega naught t. So sin pi by 4 into t. Okay, ये a1 ही था ना? हाँ, a1 and a5, correct. Okay, and omega naught is 2 pi by 8, that is the pi by 4, perfect. Okay, so 4 cos 5 by 4t minus 2 sin pi by 4t, done है? Okay, Yeah, you can enroll to the BYJU'S courses from anywhere across the world, Subhash. Okay. So Ananta, don't only think with respect to this problem कि exponential करने पे exponential expansion करने पे easy होगा, but in general, okay, the connection between the trigonometric and exponential Fourier series coefficient for gate point of view. I'm not, see, question may be whatever, but I'm not taking it as a conventional question. We have to learn what is more relevant for gate. Okay, so I think this connection has to be there. If it was not hello. Okay, yeah, I think it's okay. The mic battery was down. Now it should be okay. Okay, quickly confirm me. Now it should be okay. Okay. हाँ Nandat, I was telling you कि if it was definitely a conventional question, we will follow the expansion. But you know, rather than question, even the approach that I will tell you is what is more important for gate. Okay, and for importance of gate, looking into importance and nature of gate, you should always remember the connection between trigonometric and exponential Fourier series coefficients. That is useful in many of the questions. So that is why I gave you this particular approach. Okay, some of the time went in explanation. तो ये तो पूरा explain किया मैंने, थोड़ा बहुत formula को review किया. Otherwise, your question actually just starts from here. Only these two you need to calculate, put down. So this is what express. Okay, and the signal is expressed 4 cos 5 by 4 5 pi by 40 minus 2 sin pi by 40. Done hai? Okay, so if this is done, let's move ahead to the next question now. Okay, all right. So I think Dodge King, maybe you are mentioning this particular sawtooth waveform. It's already there. Okay, mentioning this particular sawtooth waveform. Okay, so 3.22 question. Okay, determine the Fourier series representation for the following signals. Okay, A, each xt illustrated in figure A to F. So figure A to F, again I have taken just 2-3 figures which are more relevant in gate. Some questions are purely conventional. Okay, so I'm not taking that. Okay, not taking that. Correct Ananta, है ना? Right. Then part number B, xt is periodic with period 2 and given by this formula. तो चलो पहले part number A पे आते हैं. In the part number A there are some figures. Okay, there are some figures A to F, out of which I have taken some figures. Okay, like figure A तो हमने definitely लिया है. Okay, so what is this? What is this signal? Can we express this? Okay, what is one period of this signal? Okay, what is one period of this signal? What is one period of this signal? Okay, what is one period of the signal? One period definitely is from the -1 to 1. Look into this. This is repeating. Okay, so one period is between the -1 to 1. Okay, and the time period is -1 to 1 means 2. After the time period 2, there is the repetition. Okay, time period iska hua 2. Okay, and for the time between -1 to 1, okay, the xt can be written as t. It's a straight line passing through origin and the slope is also 1. The slope, height 1, base 1. The slope is equal to 1, height 1 and base 1. Okay, xt is equal to t. xt is equal to t from -1 to 1. Okay, xt is equal to t -1 to 1. Okay, let's start with this one by one and then we will go to the others as well. Okay, so I'm solving which part? 3.22 A ka A figure. 3.22 A part, and let's complete figure number A. Let's complete the figure number A, and out of which one time period I have written. We need to find the Fourier series coefficient. I'll come to that also, Ananta. That's what I told you. Shortcut bhi nikalenge. Okay. Now, what is the Fourier series coefficient general formula? We just revised na 1 upon t integral over one time period xt e power minus jk omega naught t dt. For this particular signal, what is the time period we already discussed? For this signal, time period is equal to 2. So what will be omega naught? What will be the omega naught? That will be given by 2 pi by 2 and that is equal to pi. that is equal to pi. So dear, what is the ck? That will become 1 upon 2 integral over one time period. I told you 0 se t or minus t by 2 se t by 2. So let me take minus t by 2 se t by 2. That will become minus 1 to 1. Okay, integral minus t by 2 se t by 2 minus 1 to 1 xt. Between the minus 1 to 1, now already I told you, between the minus 1 to 1, xt is equal to t. Xt is equal to t. So t e raised to the power minus jk omega naught t dt. Now it is the integration by parts. It is going to be the integration by parts. Dhyan dena. It is going to be the integration by parts. Okay. Now integration by parts, and there what we apply is the Eilert rule. Okay, this part is exponential and this part is algebraic. Okay, so what should be the first function? Okay, t should be the first function, exponential should be the second. The sequence is Eilert. Okay, so let me just quickly apply the formula. This should be 1 by 2. Okay, now first function constant into integration of second. Acha, omega naught ka value rakhte na. What is the omega naught? Pi. So let us directly put the value pi t. Okay, so first function constant, integration e power minus jk pi t will be e power minus jk pi t upon minus jk pi. Done? Okay, minus the integral of differential of first function. Now what is the differentiation of t? It is 1, and again the integration of second function, which is e power minus jk pi t upon minus jk pi. Okay. Okay, now let's do it up, and the limit, first let me complete this integration. So this is going to be 1 by 2, this is going to be 1 by 2, okay, t e power minus jk pi t upon minus jk pi minus, okay, minus plus ho gaya ye plus, but there will be actually again a term coming up, e power minus jk pi t upon माइनस जेके पाई. तो एक्चुअली माइनस जेके पाई को रिपीट करके स्क्वायर करते हैं और इसको माइनस ही रहने देते हैं. लेट दिस बी माइनस, दिस इज द इंटीग्रल माइनस 1 to 1. ओके, माइनस 1 to 1. ओके, ठीक है, माइनस 1 to 1. यस हरी, यू कैन गो फॉर दैट ऑल्सो, यू कैन गो फॉर दैट ऑल्सो. ओके, नहीं, डिफरेंशिएशन प्रॉपर्टी से इंपल्स ट्रेन नहीं आएगा. Okay, for that you will go for double differentiation. Coming. Okay, just wait for it. Okay, if we go this way, what is the answer that you're getting? Okay, so now this is going to be equal to 1 by 2. Now put down the upper limit. Okay, yeah, actually e power minus jk pi t. Answer आ गया यहाँ से भी easily आ गया. E power minus jk pi t I have taken outside. Okay, e power minus jk pi t I have taken outside. Correct है? करेक्ट है. डिवाइडेड बाय माइनस जे के पाई भी आउटसाइड लिया. देन आई एम ओनली लेफ्ट विथ टी माइनस 1 अपॉन माइनस जे के पाई आउटसाइड, तो जस्ट माइनस 1 बाय जे के पाई. तो ये माइनस को हटा देते हैं और इसको प्लस कर देते हैं. पुट डाउन द लिमिट माइनस 1 से 1. ओके, पुट डाउन द लिमिट माइनस 1 से 1. ओके, सो दिस इज इक्वल टू 1 by 2. पुट डाउन द अपर लिमिट, तो ई पावर माइनस जे के पाई, ओके, अपॉन माइनस जे के पाई, ओके, इंटू upper limit t1 plus 1 upon 1 plus jk pi. Okay, then comes the lower limit. तो e power t का वैल्यू माइनस 1, तो jk pi, okay, डिवाइडेड बाय माइनस jk pi माइनस 1 plus 1 upon jk pi. अब इसको सब्ट्रैक्ट करने जा रहे हैं हम. Okay, now let me subtract this. So what is that I'm going to get is, dear, first of all, e power jk pi या e power minus jk pi, how much it is? Whether you take e power j pi या e power minus j pi, both are equal to minus 1. Both are equal to the minus 1. Okay. Okay, both are equal to the minus 1. Clear? Because e power j pi, cos pi minus j sin pi. Cos pi minus j sin pi. So when you take, okay, when you take e power minus j pi, वो 1 minus 1 होगा, minus 1 power k. तो my answer is going to be half. Okay, minus 1 power k अपॉन माइनस जे के पाई. ओके, ये दोनों में कॉमन है. ओके, देन 1 माइनस 1 2. ओके, 1 अपॉन जे के पाई माइनस 1 अपॉन जे के पाई कैंसिल. ओके, सो माय आंसर इज नाउ ऑब्टेन्ड. 2 से 2 कैंसिल. ओके, माइनस 1 की पावर के अपॉन माइनस जे के पाई, और यू कैन राइट डाउन 1 अपॉन माइनस जे विल बी जे. सो योर फोरियर सीरीज कोएफिशिएंट्स कैन बी रिटन एज जे इंटू माइनस 1 की पावर के डिवाइडेड बाय के पाई, डिवाइडेड बाय k pi. Okay, that is your Fourier series coefficient. ck या ak, मतलब we started by denoting it as ak. Let's keep the same terminology. This is your Fourier series coefficient, that is known as the AK. Correct? Okay. Soon after some time we'll go to the property based analysis also. Okay. Hanji. Okay. This is what it is. This is what is the complete answer for this. G minus 1 power k divided by k pi. Divided by the k pi. This is the AK. This is what is going to be the value of AK. Chalo. Now, definitely, if we go to the next, let's come here. Okay, let's come here. Acha, one more thing to observe. The signal is odd. The signal is odd symmetry. Have a look into this. Na? Positive and negative part, they differ in sign. Okay, it's clearly symmetry in the first and third quadrant. Symmetry in the first and third quadrant. It is odd symmetry. And because the signal is odd symmetric, okay, and real, the Fourier series coefficients, if you observe, the Fourier series coefficients are pure imaginary. The Fourier series coefficients are pure imaginary. Important property hota hai na? Okay, if a signal is odd symmetric, if the signal is real and odd, Fourier series coefficients will be pure imaginary, okay, and odd. Okay, so that is what is one of the property that can be employed here. Chalo, done. Okay, so this part is done. Let's move ahead to the next one. Okay, now next one is this particular picture. Before I go to this picture, is pe aate hain, B part pe. First, let me complete this B part. So what is the B part? 3.22. Let us come to the B part now. 3.22 B part, in which they have not given the waveform, they have just given the definition. Okay, they have just given the definition. Yes, Dodge. Okay, what is that definition? Xt is periodic with the period 2 and xt is e power minus t for minus 1 less than t less than t. That is directly given. Okay, xt is e power minus t for minus 1 less than t less than 1 and it is periodic with the period 2. It is periodic with the... See, if you want, sketch kar lijiye, but not required. If you want, you can sketch it out separately. Okay, but it's not really required actually. It's not really required, but if you want to go for the sketch, it's an exponentially decaying function e power minus t, okay, for t between minus 1 to 1, okay, for t between minus 1 to 1, okay, for t between minus 1 to 1, okay, okay, then after that it should repeat. This is what is the meaning of the given signal. This is what is xt. Okay, and this portion is e power minus t, the exponentially decreasing waveform from minus 1 to 1 and then repeat. Okay, then it is not repeat. Okay, then it is not repeat. Okay. Half wave symmetry check kar lete hain, kya problem hai? Okay, now half wave symmetry ke liye we shift by half the time period. Okay, if there is a doubt coming up, let's check it out. So if you shift by half the time period, what was the time period for this waveform? 2. Okay, if you shift by half the time period, okay, minus 1 will come. Half the time period means 1. T by 2 ka value 1. So minus 1, this will come here. Okay, it is going to go like this. Yes, it is not half wave symmetric. No, it is not half wave symmetric. Correct, Ghosh. Okay. So Dodge King, just check it out. Okay. It is not half wave symmetric because if you shift by half time period, okay. So if it was half wave symmetric, then after shifting by half time period, the original signal and the shifted version should differ in sign. Okay, so differ in sign कैसा होता है? इसका amplitude reversal कैसा होगा? It should have been obtained something like this, but that is not coming. That is not coming. Okay, so it is not half wave symmetric. ठीक है जी? Just check out once, Dodge, है ना? ठीक है जी. चलिए. So now this is what is the given signal. This is what is the given signal. Now, what is the Fourier series coefficients? Once again, simple. 1 upon t integral over one time period xt e power minus jk omega naught t. Time period 2 है तो once again omega naught 2 pi by 2, that will be pi. Okay, so put down the value. The time period is 1 by 2. Integral over one time period. Let's take -1 से 1 as the one time period. And between the one time period signal is exponential e की power minus t multiplied by e की power minus j k omega naught t multiplied by e power minus j k omega naught t. ठीक है? Okay, dt. Okay, where omega naught का value रख देते हैं. What is the value for omega naught? Okay, that is pi. So directly putting this value e power minus j k pi t. Okay, e की power minus j k pi t. चलो, so this should be equal to the 1 by 2. Combining both the terms of exponential, okay, you are going to get minus 21 e raised to the power minus of 1 plus j k pi whole multiplied by t dt. E power minus of 1 plus j k pi whole multiplied by t into the dt. ठीक है, this is done. Now let's solve this integration. It's a simple integration. E raised to the power minus of 1 plus j k pi multiplied by t divided by minus of 1 plus j k pi. Okay, limit -1 से 1. Okay, so let's solve with the limit. So I shall be getting half. Put down the upper limit to e power minus of 1 plus j k pi. Okay, into 1 minus the lower limit e raised to the power t minus 1 तो minus minus cancel करके 1 plus j k pi is whole divided by minus of 1 plus j k pi. Done है? So this ak is now turning out to be 1 by 2. What you can express this answer as? What you can express this answer as e power, नहीं, इसको as it is ही रखना पड़ेगा because I have combined the terms e power minus of, हाँ ठीक है, e power minus of t, correct, e power of minus j k pi t 1 plus j k pi. That's it. So we can write down that the Fourier series coefficients ak can turn out to be, shifting the minus to the numerator, okay, then you can write it as e raised to the power 1 plus j k pi minus e raised to the power minus of 1 plus j k pi whole divided by 1 plus j k pi whole divided by what? 1 plus j k pi. Okay, this should be your answer. Just check it out once. This should be the answer. Kindly check it out once. ठीक है? Kindly check it out once. अच्छा, suppose they ask you the DC component. Okay, suppose they ask you only the DC component of this one. Okay, suppose if they ask you DC component for this one. What should be the DC component? The DC component means A naught. Okay, K की जगह 0 रखेंगे तो you will get e की power 1 minus e की power minus 1 K 0 whole divided by just 1. Okay, that is the answer. Okay, calculation से check करते चलना. Okay, correct रिद्धिमान. So देखो, this is the DC component and we can calculate its value then. We can calculate its value. Okay, 1.175. This is 1.175. But if the question is only calculate the DC component, then what will you do? If the question is just calculate the DC component, then will you follow this much calculation then and put k equal to 0? Okay, for DC component, what you should do? For DC component, directly, okay, you should solve the integral 1 upon 2 integral minus 1 to 1. Okay, 1 upon t integral of xt dt for one time period. That's it. Only this should be done. 1 upon t integral over one time period xt dt. So suppose sometimes only the question can be DC component. So directly do this calculation. इतना सब करने का need नहीं होगा. So this will be equal to 1 by 2 e power minus t integral is e power minus t by minus 1 lower limit minus 1 upper limit 1. Okay, तो ये हो गया minus 1 by 2 e power minus 1 minus e power minus 1. Same answer. Minus e power plus 1. Minus को अंदर adjust करोगे तो you'll get e power 1. Okay, minus e power minus 1. Same answer. So if they only ask DC component, go this much calculation. Short and sweet. Okay. Now, let's come to the next part. Okay, let us come to the next part, the very, very important. Okay, the very, very important, that is the next part. Acha, now what can be one more way to solve this question? What can be one more way to solve this question? Okay, अब थोड़ा सा ना इसको क्विक करते हैं, अब इसको थोड़ा सा क्विक करते हैं. Okay, what can be one more way to solve this question? Okay, अब इसका complete alternate technique. Let's learn, let's keep learning. Let's be little bit more gate oriented now. Okay, let's be little bit more gate oriented. Everybody just pay attention. Everybody just pay attention. Now dear, okay, now dear, let's learn something very important. What is one time period of the signal? Okay, collect that one time period of the signal. Okay, collect that one time period of the signal. Okay, this much portion is known as, I will call it as a name XPT. I will give it a name XPT, that is known as one time period. Okay, XPT is e power minus t. Okay, minus 1 less than t less than 1. One time period information. Okay, shortcut use karenge. AK is given by 1 upon t xpk omega naught. Okay, there is the signal xpt that will have the Fourier transform xp omega. That will have some Fourier transform xp omega, using the Fourier transform to evaluate Fourier series coefficients quickly. Okay, and then the shortcut formula AK 1 upon t xpk omega naught, this can be known as this can be defined as one of the shortcut formula. Okay, because Fourier transform usually, you know, is more important for competitive exam for signals point of view. I mean, for property point of view, Fourier series coefficients are very good and tricky. But directly remembering the formula of different signals, Fourier transform, you students remember Fourier transform formula for most of the important signals. Okay, so how can you express this XPT signal? How can you express this XPT signal? ये लीजिए, समझते हैं इसको. Let it take some time, but let's understand techniques. Let's understand techniques. So what is this? Okay, if I want to discuss XPT, only one time period, let me sketch here. Only one time period, let me sketch here. And what is this one time period? This one time period XPT can be written as e power minus t. But if I write down e power minus t, it means e power minus t from minus infinity to infinity. If I simply tell you there is a function e power minus t, of course, what will you take? You will take from minus infinity to infinity. That is why I will tell you that xpt is e power minus t multiplied by a rectangle function. So see, if you take minus infinity to infinity, e power minus t, but then apply a rectangular window over it, you will get your required results. Na? You will get your required results. Na? Okay, multiply by a rectangular window whose amplitude is 1. If you take a rectangle with amplitude 1, okay, rectangle from minus 1, 7, okay, then you will get your desired results. Okay. Let me know if you have any doubts. Okay, so this is minus 1 से 1. Okay, minus 1 से 1. Okay, so इसको मैं कैसे treat कर रहा हूँ देखना. Let me draw it for you. So if I say the function is only e power minus t, only e power minus t means an exponentially decreasing function from minus infinity to infinity. But if I multiply it by a rect signal, rect from minus 1 से 1, okay. This is one of the application of rect also, creating the window for a signal, okay. If you take a rect having the amplitude 1 from minus 1 to 1 and if you multiply, so this is non-zero only between minus 1 to 1. Between minus 1 to 1, 1 into e power minus t will be e power minus t. But after this it will be 0. After 1 and before minus 1, 0, 0 into anything will be 0. So what is this signal? This is known as the rect of t by 2. What is the total duration of the rect? 2. So we define t by 2, minus 1 to 1, minus t by 2 say t by 2. So let me write down here also, this is rect of t by 2. E power minus t rect t by 2. Now why this can be easy for students? Why this can be easy for students? Because if you have done Fourier transform, especially the formula of rect, it is already there in your heart. mind, heart, everywhere it should be the rect of t by t will have the Fourier transform sampling function, sampling omega t by 2. Sampling omega t by 2. So if I use this formula, rect of t by 2, that should have the Fourier transform 2 sampling omega t by 2, 2 sampling omega t by 2. So that becomes 2 sampling omega. That is known as 2 sampling omega. Okay. So rect of t by 2 now multiplied by e power minus t. Now multiplied by e power minus t. Multiplied by e power. Acha, it's only e power minus t multiplication. Nahi, sorry. It will again take time, I think. It will again add up to some time. It is e power minus t, na? No, it will take up time. It will take up time. It is simply e power minus t multiplication. No, better go with the previous approach only. I'll tell you the shortcut in a different question, because it is not e power j k omega. If there was an exponential phase term, then definitely S shifting can be applied. यहाँ से कर सकते हैं, but that is again going to take some time. Okay, you're multiplying, then will be convolution in frequency domain. No, forget it. I'll tell you this technique in another question now. Okay, for this question, this is good. Hope you have got it. Okay, if it was e power minus jt, suppose if it was e power minus jt or something of that form, if there was a phase term, then you can apply the frequency shifting property. Okay, otherwise you will have to go for convolution. Okay, you'll have to go for convolution. No, 1 upon 1 plus j omega nahi. First of all, multiplication in time is convolution in frequency, Kumar. Okay, convolution in frequency, and moreover 1 upon 1 plus j omega is the Fourier transform for e power minus t ut, e power minus t ut, e power minus t ut. So you have to be careful about this. That is for e power minus t ut. That will be for the e power minus t ut. Clear? What is actually happening is, अरे dear, why it is not picking up the command? Chalo, forget this. Okay, yeah. Correct. So ये तो complete approach हो गया. Now let's come to the next question to talk about this particular approach. Okay. To talk even this conventional was not lengthy. Why it was not lengthy? Because it was the simple exponential integration. It was a very simple exponential integration. Okay. Now let's come to the next part. Okay, so we are done with this figure A. We are done with the part B. Now part A, figure D. I have directly taken the figure D. इसको देखेंगे. Okay, now let us learn the shortcut through it. We all know what is the Fourier transform of impulse. That is known as 1. Fourier transform of delta t is 1. उसको use करेंगे. Let's look into the next figure. That is the D. Okay, that is known as the D. And guys, what is the time period? The first impulse is at 1, then there is a negative impulse, then again the positive impulse at 2. So time period of the signal is again equal to what? The time period of the signal is again equal to 2. The time period of the signal is again equal to the 2. इसको use कर लेंगे. Okay, the time period of the signal is again equal to what? That is again equal to 2. अच्छा, within this one time period, within this one time period, what is the xpt? Now what is xpt? Xpt means one time period of the signal, and within one time period xpt is known as delta t. Okay, that is the delta t minus delta t minus 1, minus of delta minus 2 delta t minus 1. Its amplitude is 2, its area is 2, so minus 2 delta t minus 1, delta t minus 2 delta t minus 1. Okay, delta t minus 2 delta t minus 1. Okay, now let's apply the shortcut here. Okay, let us apply the shortcut here. Kya shortcut maine bola? So let us now go to, this part was done. Okay, so now same 3.22 part A, figure number D. The question figure number D. Okay, part A, figure number D. Okay, in that, what is the value of xpt? Already I told you xpt is given by delta t minus 2 delta t minus 1. Okay, so what is its Fourier transform? Using the Fourier transform to calculate Fourier series coefficient. So tell me everybody, what is the Fourier transform of impulse? 1. Okay, then minus 2. What is the Fourier transform of impulse? 1. But time shifting property, time shifting produces a phase term in the time domain, exponential term in the time domain, and that will be given by e power minus j omega. T minus 1 hai, so e power minus j omega is the phase shift. Okay, so what is the xp omega dear? Okay, that is 1 minus 2 e ki power minus j omega. Okay, now what is the time period corresponding to this signal? Already I highlighted 2. So omega naught, fundamental frequency, again 2 pi by t, so that will become pi. Okay, that will become pi. Okay, ck, the shortcut formula, is given by 1 upon t xp k omega naught. 1 upon t xp k omega naught. Use this shortcut formula, especially where? Okay, where to use this shortcut formula? Okay, especially if you feel looking into one time period. देखो हर बार use मत करना इसको. Okay, don't use it always. But if you look into one time period and you know that, अरे already I directly know the Fourier transform, because you will know the Fourier transform for many of the common signals. So if you feel one time period Fourier transform is directly known to me, then I will go for it. Then I will go for it. Why I did not use it for the A figure? चलो उस पर reason भी बताता हूँ. Why I did not use it for the A figure? We solved it by the regular conventional problem. Reason is, okay, for most of the students, okay, the Fourier transform of this straight line, that is a ramp between minus 1 to 1, is not a directly known formula. Okay, right? It's not a directly known formula. Okay, so ultimately you will spend some time calculating its Fourier transform. So if you are spending time to directly calculate the Fourier series coefficient, getting it. But looking into this, I clearly get the feeling this is impulses whose Fourier transform is known to me. Okay, so let me use the shortcut. Let me use the shortcut. So that thinking should be there in the mind. Okay, that thinking should be there in the mind. So let us apply this formula now. So ck will be 1 upon time period, that is the 2. Okay, xp k omega naught. Now what is xp k omega naught? Put omega equal to, okay, put omega equal to, okay, omega naught equal to pi, and omega ki jagah k omega naught, that is k pi. So this will become 1 upon 2. Okay, in this formula, 1 minus 2 e raised to the power minus j omega, and omega is equal to k pi. Okay, this should be the answer. We can simplify this little bit again. As I already told you, e power minus j pi is minus 1. So this will turn out to be 1 by 2, 1 minus 2, e power minus j pi is minus 1, so minus 1 ki power k. Solve ho gaya. Okay, the ck, or once again, let's keep calling it as ak only. Okay, the Fourier series coefficient ak has been obtained. Okay, 1 by 2, 1 minus 2, minus 1 ki power k. Now you can separate this also if you want. So what is the Fourier series coefficients obtained? 1 by 2, 1 minus 2, minus 1 ki power k. Now it depends whether k is even or odd. Whether the k is even or odd. Okay, whether the k is even or not. Okay. Check your expression, Anantavant. Is it what is matching here or not? Just check it out once. I'm not able to clearly read what you have written. अब देखो इसको. This can be further taken as, suppose if k is even. Suppose dear, if k is even. Okay, so minus 1 power even will be plus 1. Minus 1 power even will be plus 1. So 1 minus 2. 1 minus 2 is minus 1. So total answer become minus 1 if k is equal to even. Okay, but if k is odd, then what is the answer? If k is odd, so minus 1 power odd will be minus 1 further. So minus minus plus, so 1 plus 2 ho gaya ye. 1 plus 2 is 3. So answer will be 3 by 2 for k equal to odd. for k equal to odd. Okay, that is the answer. So like this also you can write down. Depends how the options are given. Okay, how the options are given. This is the AK complete. Okay, for the figure D. Okay, next I have taken the figure number E here. Okay, problem 3.22a. Okay, figure number E. Okay, can I try to solve it by the Fourier transform approach? Can it be simple? Because if I go by conventional method, I have to integrate. Okay, that is also okay. But can I solve it up here directly? Can I try to solve it up directly or not? Can I try to solve it up directly or not? ये सोच के देखिए. Can I try to solve it up directly or not? ठीक है, देखो. What is this one time period and what is the time period first of all? Very clearly ये है -2 से and next positive rectangle is at 4. So time period तो है 6. Time period is 6 here. Okay, what is there in the one time period? Okay, ये तो repetition हो गया. What is there in the one time period XPT? What is there in the one time period? Okay, there is a rectangle of duration 1. There is a rectangle of duration 1, rect of t by 1. Listen to me carefully. Okay, listen to me carefully. Okay, now rect of t by 1. See, when I say, let me again draw that rectangle for you. Okay, always remember standard definition of rectangle. मतलब ये, why to remember it? Because it will help you ease out the question. So if I tell you rect of t by t, na, as I already told you, rect of t by t is a rectangle, okay, whose total width is t, symmetrically located from -t by 2 से t by 2, okay, having the amplitude 1. Okay, so this is a rectangle of width 1. Okay, so I can use rect of t by 1, but problem is rect t by t is centered at the origin. उसका center origin पे होता है. Okay, but this is the centered at, क्या होगा ये, -1 or -2, -1.5. Okay, and like this is, okay, if I only tell you take rect t, so -0.5 से 0.5 आना चाहिए. So this is like left shifted. This is like left shifted. You know what to do for left shifted? T is replaced by t plus something. T plus कितना? Sorry, 1.5. It is left shifted by 1.5. So t will be replaced by t plus 1.5. Okay. Minus, now there is another rectangle, negative amplitude. So minus of rectangle, that is also having the width 1. That is also having the width 1. Okay, and centered at between 1 to 1.5. So this is like right shifted. So t minus 1.5. Now you can do it up and get your answer. Now you can do and get your answers easily because Fourier transform of rect, बाबा पता होना चाहिए. Fourier transform of rect, very very important formula. Rect, trie, sampling square, everybody must remember. If you don't remember, your Fourier transform is not that strong. Okay, anyways, we will come to next chapter is CTFT only, continuous time Fourier transform. Next chapter वही discuss करने वाले. ठीक है, so let's come up here. Okay, so this is the E picture. (3.22) part A, figure E. Okay, part A, figure E. What is the XPT? What is the XPT? Rect of t plus 1.5 upon 1 minus rect of t minus 1.5 upon 1. Okay, that is what it is. Okay, that is what it is. Chalo, quickly do it up. The formula I already told you. What is the Fourier transform for rect of t by t? Time shifting to apply ho jayega. Okay, the Fourier transform is given by t sampling omega t by 2. So if I use this formula, what will be xp omega? Okay, rect of t by 1. Time shifting later on, so t by 1. Okay, so 1 into sampling omega into 1 by 2. So sampling omega by 2. Okay, if I only take rect t, sampling omega by 2, but rect t plus 1.5, time shifting produces phase term in the frequency domain, exponential term, that will be e power minus j. Okay, sorry, plus j होगा, t plus 1.5 है, तो plus j 1.5 omega. Okay, plus j 1.5 omega, e power j omega t naught, e power j omega t naught, and t naught plus 1.5 है. Okay, next minus for the function rect t, again it is sampling omega by 2, but multiplied by what? Time shifting, the e power minus j, okay, 1.5 omega. Okay, chaliye. So now what is the xp omega? Sampling omega by 2 common. sampling omega by 2 common. So I should be getting e power j 1.5 omega minus e power minus j 1.5 omega. Okay, that's it. So if you divide by 2j, it will become the sine theta formula. If you divide this by the 2j, e power j theta minus e power minus j theta divide by 2j. Okay, so you'll get sine theta. So divide by 2j multiplied by 2j, your xp omega has turned up to be 2j sampling omega by 2 into sine theta, where theta is 1.5 omega. Theta is 1.5 omega. Okay, now dear, what is the time period of the signal? Was 6. So omega naught is given by the 2 pi by 6, or that is known as pi by 3, and my Fourier series coefficient shortcut, if I again use, ak will be 1 upon 6 xpk omega naught, the xpk pi by 3. So in the expression obtained for xp omega ki jagah pi by k pi by 3. So 2j into sampling of k pi by 3 divide by 2 into sine of 1.5 into omega, which is k pi by 3. Okay, so the ak after solving up 2j by 6, that is j by 3, sampling of k pi divide by 6 sine of 1.5 by 3, तो बचेगा k pi by 2. That will be what? K pi by 2. Let me also tell you that whenever you take any even value of k, the answer will be 0. Why? Okay, whenever you take any even value of k, the answer will be 0. Why? Okay, even value 2 या 4. So if you take even value, you'll get sine pi, या sine 2 pi, sine 3 pi. All this will be 0. So ak will be equal to 0 for any even value of k. ये भी ध्यान रख लेना. For all even value of k, ak will be 0. Okay, ak will be 0. Okay, so if you take k, 2, 4, 6, etc., the Fourier series coefficient will be 0. This is the general formula. Okay, so whenever you look into the one time period and if you get the feel कि इसका Fourier transform पता होना चाहिए, and you must know, otherwise your Fourier transform, again I repeat, if you don't know what is the Fourier transform of rects, your Fourier transform is incomplete. You're not strong in that. Okay, ठीक है. अच्छा, now time period is 6 na, everybody. One more observation. Time period 6 है. Shift by half time period. Dear, shift this waveform by half time period. Minus 2 plus 3. Half time period means 3. So shift by half time period. Minus 2 plus 3 will get 1. Okay, so ये वाला आ जाएगा. So if you shift it by half time period and 1 plus 3, that will go to 4. देखो ये shifting होगा. So if you shift it by half time period, okay, the shifted waveform, half time period shift है ये. The shifted waveform and the original waveform, they are just opposite in sign. Okay, shifted waveform, नीचे blue वाला, and the original waveform, opposite in sign. Such a symmetry is half wave symmetry. Okay, so this waveform is also half wave symmetric. See, whenever you shift by t by 2, नीचे वाला visible है ना? हाँ. Whenever you shift by t by 2, okay, plus or minus anything, whether you right shift or left shift, doesn't matter. Okay, if it turns out to be minus of xt, the signal is half wave symmetry, and always half wave symmetric signal will contain odd harmonics. ये नियम है, very important rule, please note down. अच्छा, at the same time, signal is odd symmetric. There is a symmetry in the second and fourth quadrant, na? Okay, the signal is it's odd symmetric. Okay, because the signal is odd symmetric, keep noting, the signal is odd symmetric. Okay, the Fourier series coefficient, the signal is real and odd. Real to hai. The signal is real and odd. Fourier series coefficients, pure imaginary. It is starting with j into something. Okay, pure imaginary. And because of half wave symmetry, ak is 0. For even harmonics, not always, for even harmonics. Okay. Half time shift only, na? Half wave symmetry का identify करने के लिए, that is the simple way. Just shift the waveform by half period, and if the original and the shifted waveform, they are just differing plus minus sign. Okay, one is plus, another one is minus, same level. So that is what is half wave symmetry. AK is equal to 0 for K equal to even. Why? This has happened because of half wave symmetry. Because of half wave symmetry. ठीक है? Done है? चलो. So these are all decent problems to learn. Okay? These are all the decent problems to learn. Correct? Done. Let's move ahead. So dear, yeah, before I move forward, let me just give you a quick reminder that for GATE 2024, okay, now the BYJU'S exam prep starts the free MMC Mega Mock Challenge. Now signal is not even, signal is odd, the given signal is odd, Ananta. Okay, so Mega Mock Challenge, MMC, okay, the open Mega Mock is free for all students. Okay, the first Mega Mock starts from 14th October, that is tomorrow, and it will be there up to 20th of October. Okay, so you can utilize this mock test for your practice. Okay, initially you have some subject, okay, mixed subject mock test, and then last May you'll have the full GATE mock test as well. All of these are free, I repeat, on the BYJU'S exam prep app. Okay, so so you'll have GATE mixed subject test 1, mixed subject test 2, like the test that is starting tomorrow 14th October will have aptitude, maths and control system, some fundamental subject, but the questions will be 65, 100 marks and 180 minutes. Okay, so that is starting tomorrow. It will be live up to the 20th October. Now you can utilize this for your practice, and one more important thing is the result of the first MMC is announced on the 21st. 20 koi over hoga, it is announced on 21st, and based on the results, you can also get discounts on the BYJU'S exam prep test series. So you can perform in the MMCs and you can get the test series enrolled for you at the lower price. Okay, so everything, all of this available on the BYJU'S exam prep app. Okay, acha. Also let me tell you parallelly, okay, this BYJU'S exam prep app, there are multiple other practice quizzes, so you can download if you don't have from the Google Play Store, or there is a link in the description of the video. You can directly download using that link. Okay, yeah, you can give on any particular of the 6 days, 14th to 20th October, any day, any time. Okay, any day, any time. Okay, chalo dear, let's go ahead to the next. This is more like a logical question. Have a look into this question. Yeah, more open Mega Mock, free. Because it is a symmetry in second and fourth, na? Yeah, again you can check, Ananta, x minus t is minus xt. X minus t is minus xt. Okay, chaliye aate. Consider a continuous time LTI system whose frequency response is given to you. H of j omega equal to 1, mod omega greater than 250. Okay, otherwise 0. Okay, when the input to the system is a signal xt with the fundamental period t pi by 7 and the Fourier series coefficient ak, it is found that the output yt is identical to xt. It is found that the output yt is identical to the signal xt. For what values of k is it guaranteed that ak will be equal to 0? AK will be equal to the 0. Okay, the input to the system is a signal xt with the fundamental period, okay, pi by 7. Okay, the fundamental period of the signal is pi by 7. Okay, so what is the frequency? Fundamental frequency 2 pi upon omega, 2 pi by t. So pi cancel, 2 7s are 14. So there is the fundamental frequency of the signal, that is omega, that is 14 omega naught. Okay, but when you have a periodic signal, okay, period bola to periodic hai. The periodic signal, okay, can be represented in Fourier series, and every periodic signal can be broken into its multiple harmonics. Okay, multiple harmonics. So what are the harmonic frequencies? What are the harmonic frequencies for a signal? In general, okay, it is given by k omega naught. Okay, in general it is given by k omega naught, right? That is, okay, it can be 0, it can be plus minus omega naught, first harmonics, that is a fundamental term, this is the DC term, then it can be plus minus 2 omega naught, then it can be plus minus 3 omega naught, and etc. So there is a signal xt and that has the Fourier series coefficients ak. Okay, there is a signal xt and xt has the Fourier series coefficients ak. Okay, now I pass this system through a LTI system whose frequency response is given, and it is found that the output is identical to the input. Kya mila? Very good logical question. Conceptually it is very good. Okay, the output is identical to the input. Now let me first draw this. Let me first trace this frequency response. Okay, very important to trace this frequency response. Okay, what is that frequency response? It is equal to 1 only for mod omega greater than equal to 250. Okay, only for mod of omega greater than or equal to 250. Okay, greater than or equal to the 250. It will be 1. Okay, mod omega greater than 250 means omega greater than 250 or omega less than minus 250. किसी भी साइड में magnitude लोगे, it will be 1. It will be 1. This is what is omega. Okay, this is the h omega. Okay, which is equal to 1 for omega greater than 250 or less than minus 250. Clear? So what is this basically? Basically, this is nothing but a high pass filter. Okay, high pass filter, and 250 can be known as the cutoff frequency. It only passes the high frequency. It only passes the high frequency. Okay. Now, what is the output yt? What is the output yt? What is the output yt? Okay. Output yt is identical to the xt, but suppose if the signal xt has any frequency component up to 250, and when you pass it using the high pass filter, that frequency component will be rejected, and that should not appear to the output. Okay, that should not appear to the output. Okay, so what you are given, yt is equal to xt. Okay, yt is equal to xt. Okay, but yt as per this filter, okay, yt can only have the frequencies that is omega greater than 250 only. Okay, right, this is the output of high pass filter. So it can have the frequencies only for omega greater than 250, because if input was having any frequency in this range, it is rejected by the filter, high pass filter, hai na? Okay, so if yt is equal to xt, I can say that xt should also have the frequencies omega which is greater than 250. Can I say that? It should also have the frequencies which is greater than the 250, which is greater than the 250. Okay, ठीक है. अनंता बैंड स्टॉप तब होता है ना, if it stops a particular band between omega 1 to omega 2, a particular positive band between omega 1 to omega 2, that is band stop. This is clearly high pass. Okay, when it passes from up to omega c up to the infinity. No. For symmetry point of view, we draw the negative frequency, but actual filter analysis defining its bandwidth and cutoff frequency, Ananta, is only done considering positive frequency side. Isko dekhoge. Look into this. How it is band stop? It is high pass, na? Okay, what is band stop? Band stop tab hota if it has something of this kind. It is stopping this particular band. Okay, stopping this particular band. ठीक है, चलिए आ जाते. So xt should have the frequencies greater than 250. Okay, so what are the frequencies of xt? Okay, what are the frequencies of xt? ये देखते हैं. Okay, हमें मिला, if I talk about xt, it has the omega naught which is 14. Okay, so what are the frequencies available? Okay, frequencies are always in the form of k omega naught, so that will be 14k. That will be 14k. ठीक है, अब आप एक सिंपल सा लॉजिक अप्लाई करो. द कट ऑफ फ्रीक्वेंसी, okay, the cutoff frequency omega c divided by the harmonics of the signal. Cutoff frequency is 250. Okay, if you divide by 14, chalo, k omega naught me, just try to divide by 14. Okay, when you divide by 14, what is the answer coming up? Okay, when you divide this by the 14, what is the answer coming up? That is 17.85. That is 17.85. That means when you take 14 into 17, lower part, what will be 14 into 17, dear? 1 second. What is the 14 into 17? That is 238. Okay, but if you take 14 into 18, that is 252. This should be there, it should not be there. Okay, it should have the frequency, what I told you, okay, which is greater than 250. Okay, which is greater than 250. Okay, so 14 into 18 is allowed. Okay, 14 into 19 will be allowed because this will be further 266. That is allowed. Okay, so I can say that k should be greater than or equal to the 18. K k should be greater than or equal to 18. So my answer is the Fourier series coefficients must be 0, okay, for mod k less than equal to the 17. Okay, mod k मतलब negative side में भी नहीं होना चाहिए ना. I've done the positive calculation result. तो ak should be 0 for mod k less than equal to 17. That is the answer. Any doubt, please ask me. I shall just be back. Okay, yeah, done. No, minimum k is not 17, Divan, it will be 18. If you do 14 into 17, then also you get the frequency less than 250, na? You want frequency greater than 250. Very beautiful. Okay, lag raha hai, it's a fundamental conceptual very good question. Fundamental and conceptual and very good question. Okay, let's move ahead to the next question then. Okay, let us move ahead to the next question. Okay, yeah, some property based question now. Okay, let xt, okay, be a periodic signal with the fundamental period 3 and Fourier series coefficient ak. Derive the Fourier series. Derive nahi, hum property based karenge. Let us not derive, let us apply the property of each of the following signal. xt minus t naught plus xt plus t naught, one by one. Quick and simple. Okay, a part. xt is having what Fourier series coefficient? Okay, it is having the Fourier series coefficient ak. Okay, a part xt minus t naught plus xt plus t naught. This should have the Fourier series coefficient ak. Now xt minus t naught e raised to the power minus jk omega naught t naught. Okay, plus ak e raised to the power plus jk omega naught t naught. Time shift property of Fourier series coefficient. Okay, x of t minus t naught will have the Fourier series coefficient that will have the phase term e power minus jk omega naught t naught. E power minus jk omega naught t naught. Now out of this ak is common and you are left with e power. Okay, directly answer likh de. E power ak common, e power minus j theta plus e power j theta. That can be written as 2 cos theta. Okay, that can be written as 2 cos theta. So 2 ak cos theta. Theta is equal to k omega naught t naught. Theta is equal to k omega naught t naught. Done? Okay, 2 ak cos k omega naught t naught. That is the part A. That is known as the part A. Okay, now part B, even part of xt. What is the part B? Even part of xt. Okay, let's come to the next. Even part of xt. Now, what is the even part of xt actually? xt plus x minus t divided by 2. That is the formula for even part of a signal. What will be the Fourier series coefficient? What is the Fourier series coefficient for xt? It is given by ak. What is the Fourier series coefficient for x minus t? That is given by a minus k. Okay. Folding in time corresponds to folding of the Fourier series coefficient, folding in frequency domain. Okay, so answer is simply ak plus a minus k by 2. It is nowhere mentioned that the signal is real. Nowhere mentioned signal is real. Otherwise, I can take a minus k equal to ak conjugate. No, so my answer is only ak plus a minus k by 2. Okay, Dodge King. Real part of ak, again, if it is a real signal. Okay, you are applying conjugate symmetry there, not applicable because nowhere it is mentioned signal is real. So it is any general signal. Answer is only ak plus a minus k by 2. That's it. You have to stop here. Okay, okay. Now see. चलो मैं ऐड कर देता हूं. If it is by chance a real signal, if xt is real, then your result will be applicable. Okay, if xt is real, then a minus k is ak star. Okay, and then your answer will be ak plus ak star divided by 2. A signal, when it is added with the conjugate, only real part will come, twice the real part. X plus jy, x minus jy, what will you get? X plus jy, x minus jy, you will get 2x. Jy minus jy cancel, 2x upon 2x. X matlab real part of ak. Okay, so even part of xt can have the Fourier series coefficient real part of ak, but that is for real signal. यहाँ पे real नहीं बोला है, so this has to be the general answer. This has to be the general answer. ठीक है. Similarly, part C, real part of xt now. Part number C. Okay, considering the real part of the xt. Okay, so what should be the real part of a signal? The real part of a signal is obtained by adding the signal with its conjugate and then divide by 2. Just now I explained you, na? X plus jy, x minus jy, 2x, divide by 2x, you get the real part. Okay, so what is the Fourier series coefficients now? Okay, xt having the Fourier series coefficients ak, x conjugate t dear has the Fourier series coefficient a minus k star, then divide by 2. Some fundamental results directly you should know. Okay, so x conjugate t has the Fourier series coefficient a conjugate minus k. Okay, so this is the answer. Okay, next wala, what is the next fourth part? Okay, d2x by dt square. Okay, now first derivative will introduce jk omega naught. Second derivative will introduce jk omega naught whole square. In general, the Fourier series coefficients are jk omega naught power n if it is nth derivative. Here it is second derivative, so jk omega naught whole square into the ak. Jk omega naught whole square into the ak. So this will become j square will be minus 1 actually. Okay, so minus of k square omega naught square ak. That is the answer. Minus of k square omega naught square ak. That is the answer. Or you know, it can be also written as minus k square omega naught is 2 pi by t. Okay, so 4 pi square by t square ak. It can also be written in time period form. Depends again how the options are given. Depends again how the options are given. Okay, that is the answer. Minus k square 4 pi square by t square ak. ठीक है, डन है. नेक्स्ट वन. Okay, x3t minus 1, and ये नहीं भी बोलते, they have given a very clear hint that for this part first determine the period of x3t minus 1. Period of x3t minus 1. Okay, what is the period of x80? ये तो basics of signal में already we have solved यार. What is the period of x80? Whenever a signal is scaled, what is its time period? Okay, what is its time period? It is given by t by a. It is given by t by a या t by modulus a. It is given by t divided by mod a. ठीक है जी. Okay, so now e part, x of 3t minus 1. Let's talk about this separately. We have the e part. Okay, that is known as the x of 3t minus 1. Okay, one by one चलेंगे. Okay, so what is the Fourier series coefficient for xt? That is known as xa. What is the Fourier series coefficient of xt minus 1? Precedence rule. We here also apply the precedence rule like I told you chapter number 1. Shift and scale. First shifting करेंगे. तो xt minus 1 that has the Fourier series coefficient ak e raised to the power time shift exponential term e power minus jk omega naught into t naught. That is t naught का value 1 है. E power minus jk omega naught into 1. Okay, but now I will introduce x3t minus 1. Okay. Now I will introduce x3t minus 1. Let me tell you one property. Shifting को अगर हटा भी दे. Okay. In general, dear, if xt has the Fourier series coefficient ak, okay, x of at, is there any effect on Fourier series coefficient by time scaling? What is the time scaling property of Fourier series coefficient? Time scaling does not affect the Fourier series coefficient. Okay, for x80 it remains to be ak only. It remains to be ak only. So here I am doing the time scaling only. Okay, तो Fourier series coefficient में तो affect नहीं आएगा, k will remain to be k, but there will be effect on the frequency actually. There will be effect on the frequency. E power minus jk, e power minus j k में affect नहीं होगा, but frequency will change. How much? Time period will be t by 3, so frequency will become 3 times. Na? Time period is t by a, so frequency will multiplied by a. Frequency and time period reciprocal. So frequency will become 3 omega naught. Frequency will become 3 omega naught. So for this signal, as I told you, time period becomes t by a, that is t by 3. So omega dash will become reciprocal of this, that will become 3 of omega naught. 3 of omega naught, that is what is substituted there. So your answer should be ak e power minus jk 3 omega naught. Okay. That's why I applied mod a, na? Yes. Okay, a less than 0 means negative, that includes folding actually. Okay, so folding doesn't change the time period, na? Okay, so that is ak. Coefficient sign will change. Haan, wo to hoga. You are talking about coefficient also. Okay, that is the property we applied here also. If you take x minus t, it will be a minus k. But here it is not negative, na? Here it is x3t. Okay, xat will have the Fourier series coefficient ak. Of course, in this property, a positive, of course a positive, because if a negative, that is like folding, na? Folding already used, the folding point is already used. ठीक है जी, done है, done है. So answer is ak e power minus jk 3 omega naught. Okay, these are very much relevant gate questions. Okay, little bit data change, but you can see these questions in the previous year's question. That is why open-em questions, I told you, very much relevant with the gate question, very much relevant with the gate questions. Next. Again property based, pure conceptual and property based. Xt be a periodic signal whose Fourier series coefficients are given to you. Ak equal to 2 for k equal to 0, or else it is equal to j half power mod k. Okay, is the use Fourier series property to answer the following question. Is xt real? Is xt real? Is xt real? Is xt even? फिर d by dt पे बाद में आते. Okay, let's write down this ak here. It's a very simple question actually. ak is given to you as 2, that is a DC component k equal to 0, and for k not equal to 0, it is written as j, okay, half raised to the power mod k, half raised to the power mod k otherwise, that is for k not equal to 0, for k not equal to 0, okay, yeah, easily. Now, a minus k, what is the a minus k here? So if you replace k by minus k dear, mod of minus k, देखो, if you replace k by minus k, तो 0 पे तो effect नहीं आएगा, a minus 0 is a0, so this remains to be 2, okay, for minus k equal to 0, okay, minus k 0 means k 0, that is equal to j half raised to the power mod k, okay, because modulus of minus k is modulus of k, inside the modulus no role of minus, na? Modulus of minus 1 is 1, ठीक है. So okay, for k not equal to 0, I mean minus k not equal to 0, so k is also not equal to 0. Okay, here I can say minus k equal to 0, but k equal to 0. Minus k 0 means k is 0. So ultimately a minus k is equal to ak. A minus k equal to ak. चलो इसको छोड़ो, पहले a के conjugate भी निकालते हैं. Now what is ak conjugate? Now take the conjugate of this. Only we have to take the conjugate. So 2 is a real number, conjugate will be 2 only. Okay, now this is some real part like jy, so conjugate will become minus j. Conjugate will become minus j. So minus j half power mod k for k not equal to 0. Okay, this is ak star. This is what is ak star. Now if you pay attention that dear, okay, is the a minus k equal to ak star? Is the a minus k equal to ak star? No, they are not equal actually. They are not equal. A minus k does not equal to ak star, so there is no conjugate symmetry. Okay, there is no conjugate symmetry. There is no conjugate symmetry. The signal is There is no conjugate symmetry. The signal cannot be real. Okay. The signal is non-real. The signal is non-real. Okay. But at the same time, A minus K equal to AK. Fourier series coefficients show even symmetry. A minus K is the coefficients of x minus t. AK is for xt. Okay, so the signal is even. So the signal is even. The signal is even. ठीक है? अच्छा, if a signal is even, ये भी directly बोल सकते हैं. So what is the derivative of a even signal? Guys, maths का result apply कर लेंगे ना. No need to go for Fourier series coefficient of d by dt xt. Okay, right. So that is odd. That is odd. Okay, so is xt real? No. Is xt even? Yes. If xt is even, its derivative will be odd. So is derivative even? No. Okay, so only B part is yes, rest all is no. Okay, that's what I'm telling. We can easily frame up. What? We can frame up what? Just a second. Yeah. MSQ question can be framed up from here. Okay, MSQ question can be framed up from here. No, not purely. It's not purely. Xt can turn up to be even later on, but Ananta, Ghosh, it's not purely because. अच्छा हाँ, ये तो रियल है ना. Conjugate, इसका conjugate a minus k is equal to a k star minus. नहीं देखो what is देखो just carefully check. Okay, what is conjugate entry symmetry? A minus k should be minus of ak conjugate. Okay, अब minus of ak conjugate. Okay, so this 2 and minus 2, this will not match ना. You are only looking into this part for k not equal to 0, but ये match नहीं करेगा ना. Okay, so just check it out, Ghosh. Okay, only maybe you're looking into this part, but what about this? A minus k should be minus ak star, but when you take minus ak star, ये तो इसमें convert हो जाएगा, but minus 2 will not be equal to 2 ना. ठीक है जी? So no, we can't call xt as imaginary. It's only non-real. It's general complex number. मतलब not pure imaginary. That will be a real plus imaginary part both. चलो done. Next, again a property-based question. Okay, we are given the following information about a signal xt. That xt is a real signal. Okay, xt is periodic with period t equal to 6 and the Fourier series coefficients ak. Okay, ak equal to 0 for k equal to 0 and k greater than 2. Acha. AK, one by one, let us write down some information here only. Okay, dear, what they are telling is AK equal to 0 for k equal to 0 and k greater than 2. So only what is the meaning? A1, k 0 पे भी 0 है, k greater than 2 पे भी 0 है. So what can only take place is k equal to 1 and 2. Okay, that means A1 and A2 are non-zero, and so will be A minus 1 and A minus 2. A minus 1 and A minus 2, that will also be non-zero. Ye clear ho gaya? One by one let us deduce. At the same time xt is real because of real signal. Okay, conjugate symmetry will be there. A minus k equal to ak star. Okay, period 6 hai. Okay. Now 1 by 6 integral minus 3 to c mod xt square dt is equal to 1 by 2. What is the meaning of this statement? And a1 is a positive real number. Okay, acha, first let's use this. Then fifth to easy aa jayega. Xt is equal to minus xt minus 3. Let us use this fourth point. Okay, we'll get something if I use this 4 point. Okay, so what do I have? Okay, x of t is minus xt minus 3. So if two signals are equal, their Fourier series coefficients will be equal. This has the Fourier series coefficients ak. This will have the Fourier series coefficient minus as it is likha ak into e power minus jk omega naught t naught, that is e power minus jk omega naught into 3. But what is the value of omega naught? What should be the value of omega naught? T6 hai, so omega naught will become 2 pi by 6 or that is known as pi by 3. Omega naught will be the pi by 3. ठीक है, right, will be the pi by 3. So what is the value of ak? Okay, that is minus ak e power minus j k omega naught. Omega naught कितना रखा था हमने? pi by 3. Okay, so pi by 3 into 3 is pi, and e power j pi, I already told you today only multiple times, e power minus j pi will be minus 1, so minus 1 power k can be written. Okay, अब बता दो. So you are getting ak is equal to minus ak minus 1 की power k. So out of this if I take k even, so what are you getting? K even, तो minus 1 power even will be plus 1. Minus 1 की power even will be plus 1. ak is minus ak. That is only possible. That is only possible if ak is 0. A number and its negative is same. That is only possible with 0. 0 has no effect of the sign. Okay, so ak will be 0. अच्छा, ak 0 है, and already I told you that, okay, that only a1, a2 are possible. Out of that, a2 also 0. Okay, so a2, which is also equal to a minus 2, they are 0. Okay. अच्छा, a minus 2 डायरेक्ट नहीं बोलते हैं, अभी हम बोलते हैं a2 is 0, so a minus 2 which is a2 conjugate, that will be 0. ठीक है. Now if you take k odd, if you dear take k equal to odd, okay, then you are left with the equation ak is minus ak into minus 1 की power odd. Okay, so that means you are getting a relation ak is equal to ak. अरे बाबा, ak तो ak हो गई. What is the new discovery here? ak will be ak, nothing new. Okay, that means a1 will exist. It can be non-zero, and already mentioned a1 is a positive real number. Now point number 5. What is the point number 5? It is going to be applied by a theorem. What is the point number 5? Okay, ये तो point number 4 से deduce किया. What is the point number 5? 1 upon 6 integral minus 3 से 3 mod of xt square dt is given as 1 by 2. This is like a expression 1 upon t, time period 6 है, integral over 1 time period mod of xt square dt is known as the time average power of a signal. This is the formula for time average power of a signal. And time average power of a signal, okay, by Parseval's power relation, it is given by summation of mod ak square for all values of k. Okay, for all values of k. That means summation k minus infinity to infinity mod ak square is 1 by 2. ये right hand side पे 1 by 2 है. Parseval's theorem. Now, okay, now only possible value is, okay, ak equal to non-zero only for k equal to 1. केवल k equal to 1 बचा ना. Okay, so that means, okay, summation for k equal to plus or minus 1, both will be left है ना. K equal to plus or minus 1. तो summation k is minus 1 and 1. Only two values will be left. Mod ak square तो पूरा निकालते हैं ना. Okay, mod of a1 square plus mod of a minus 1 square will be half. Okay, conjugate symmetry क्या suggest करेगा? Conjugate symmetry suggest करेगा that a minus 1 equal to the ak star, but a number and its conjugate, that will have the same magnitude, na? A number and its conjugate, that will always have the same magnitude. Okay, that will always have the same magnitude. So modulus of a minus 1 will be modulus of a1. Okay, so ये हो गया twice modulus a1 square is 1 by 2. Modulus of a1 will be 1 by 4. 1 by 2 directly value रखें तो modulus of a1 will be 1 by 2 or 0.5. And it's a positive real number. ये बोला था ना? It's a positive real number. a1 is positive real. Okay, so a1 is 0.5. Positive real है ना? a1 is 0.5. Okay, so what is a minus 1? a1 star, but it's a positive real number, तो conjugate लेने का कोई मतलब नहीं है. It is 0.5. Both are 0.5. Both are 0.5. Okay. Show that the signal xt is a cos bt plus c. Determine the value of a plus a b c. Now in the gate they can put you NAT question. Okay. अगर ये question gate में होगा suppose. Okay, they can put it as a question. Find the value of a plus b plus c equal to. Numerical answer type question. The signal can be expressed as a cos bt plus c. Find the value of abc and find a plus b plus c. Okay, a plus b plus c. ठीक है? Yes. Yes, Ghosh. This similar type of questions you can relate in the gate. That's what I'm telling. इसलिए ये book बहुत important है आपके लिए. Okay, so this part is done. Okay, so only what is the xt? भाई अगर अब फोरियर सीरीज की बात करें, एक्सपोनेंशियल फोरियर सीरीज की बात करें, तो इट इज गिवन बाय समेशन ए के ई पावर जे के ओमेगा नॉट टी फॉर ऑल वैल्यूज ऑफ के, बट यू विल ओनली पुट डाउन के इक्वल टू प्लस माइनस 1. ओके, तो एक्स टी विल बी इक्वल टू a1 का वैल्यू हाफ ई पावर जे ओमेगा नॉट टी, राइट, ई पावर जे ओमेगा नॉट टी वेयर ओमेगा नॉट इज π/3, पूरा वैल्यू ही रखते हैं. Okay, तो e power j k π/3 into t plus a minus 1 that is also half e power okay k minus 1 तो minus j, अच्छा k का वैल्यू तो 1 रख दिया था, तो डायरेक्टली π/3 e power j π/3 and this will be e power minus j π/3t. Okay, so what is the value of xt? E power j theta plus e power minus j theta by 2 and that is known as the cos theta, that is cos theta cos π/3t. Now I have to compare it with a cos of bt plus c. Okay, and then I will give you the answer. What is a plus b plus c? Numerical answer type question. Comparing a, amplitude is 1, b is the omega, that is equal to π/3, and c is some initial phase, that is 0. Okay, so what is the numerical answer type question for this one? 1 plus π/3. Okay, so that is gonna be how much? Okay, that is 2.047. That is known as 2.047. This is what is known as the 2.047. 2.047. Done hai? All cool. That is the 2.047. Chalo, done. One more question, not exactly same, but isi tarike se some facts and figures are given about the signal. These are all very important questions. Suppose we are given the following information about a continuous time periodic signal with period 3 and Fourier series coefficient ak. ak is ak plus 2, ak is a minus k. Okay, integral minus 0.5 से 0.5 xt dt is 1 and similarly integral 1 से 2 xt dt is 2. Determine xt. Determine xt. Okay, ak is ak plus 2 and ak is a minus k. Okay, ये दो information है मेरे पास. Okay, now ak is a minus k. Okay, that means xt is x minus t. The signal definitely must be even. The signal definitely must be even. Okay. Acha. Now, let's come to the first point. ak is ak plus 2. Acha. Frequency shift. Frequency shift, or you can call it as the k shift. Okay, frequency shift or k shift will occur when there is the exponential term in the time domain. Okay, when there is the exponential term in the time domain. So ak is the Fourier series coefficient for xt. ak plus 2 should be the Fourier series coefficient of xt, and in the frequency shift sign is opposite. If it is k plus 2 here, so e raised to the power minus j. Okay, how much k omega? How much is the shifting by k naught? That is 2. So 2 omega naught t. Okay, right. E power 2 omega naught t. E power minus j 2 omega naught t. Okay, acha, now let us again put down the value of omega naught, which is π/3. Okay, π/3 tha na? It was π/3 only, correct. So what is the value of xt? Nahi, yahan pe, sorry, that was a previous question. Here the period is 3, I'm sorry. Okay, here the period is 3, so here omega naught will be 2 π/3. That π/3 was for the previous question. Okay, तो ये हो गया 2 π/3. Let me correct this. Okay, that is 2 π/3. So xt is equal to xt e raised to the power minus j 2 to the 4 π/3t. E power minus j 4 π/3t. That is the value of xt. अच्छा, Now what is the meaning of this? Can I cancel xt? Okay, let me cancel xt. So dear, if you are trying to cancel xt, you will get 1 equal to e power minus j 4 pi 3t. That is not possible. That is not possible. ऐसा होना possible नहीं है. But yeah, see, either xt will be 0. ठीक है, either xt will be 0. Okay, so if xt is equal to 0, then you get 0 equal to 0. If xt itself is 0, okay, then 0 0. ठीक है, but if xt non-zero, there, that's what घोष उसको समझते हैं. So if xt is non-zero, then what is the equation you are getting? 1 equal to e power minus j 4 pi by 3 into t. Is it possible? Is it possible? If this is possible, then let us compare both in the exponential form. 1 can be written as e power minus j 2 pi. Not only e power minus j 2 pi, it can be written as e power minus j 2 pi into m, where m can be any integer. Even 0. E power 0 will be 1. E power 0 will be 1. Okay. E power j 2 pi will be 1. Cos 2 pi minus j sin 2 pi. Na? E power j 4 pi, again 1. Okay. Ye sab 1 hoga. Okay. So now I can compare it with the left hand, right? So if I compare j ko hata de, 2 pi m is being compared with 4 pi by 3t. So that is only possible for t equal to, ये हो गया 3, pi cancel by 2, 3 by 2 m or 1.5 m. That means there is an information about the signal that xt is not equal to 0 only for t equal to what times? 1.5 m. 1.5 m. That is t may be 0. M can be any integer, na? Okay, so m can be 0 also. If you take m1, so t may be plus or minus 1.5. If you take m2, so plus or minus 3, and etc. So xt is only non-zero at some special points. Okay, at 0 or at 1.5 or at 3 or etc. Now, okay, now there is this statement number 3, minus 0.5 se 0.5 xt dt is 1. Xt is a 1 point signal. Okay, now statement number 3, integral minus 0.5 say 0.5 xt dt is equal to 1. But between minus 0.5 say 0.5 xt only exists at t equal to 0. Okay, so there is only a 1 point signal whose area is 1, and that is only possible for impulse. Okay, tell me yes or no. Okay, there is only a 1 point signal. There is only, between the given limits, there is only 1 point where signal is non-zero. Okay, t equal to 0, but the area of it is 1. That is only possible that xt is equal to delta t. Xt is equal to delta t in this particular range. In this range. Okay, right, so I can say like that, in this range means xt contains delta t. Okay, similarly dear, there is the fourth point given, integration 1 से 2 extra t xt del t, and that is equal to something. कितना given है? Integral 1 से 2 the xt delta t is equal to 2. Okay, but again, between the limit 1 say 2, t is only defined for 1.5. T is only defined for 1.5. Okay. So, there is a 1 point signal whose area is finite. That is only possible. A 1 point signal whose area is finite, that is only possible as an impulse. Okay, area is 2. So, it will contain 2 delta. But at what point? 1.5. So, 2 delta t minus 1.5. 2 delta t minus 1.5 हो गया रे question आपका. Okay, हो गया. Because after that the next possible signal is at 3, but 3 पे तो repetition होगा. Remember time period is 3. So whatever at 0 automatically repeats at 3. So don't look into the repetition. Okay, so for one time period, okay, what I can say, okay, for one period that is 0 less than equal to t less than 3, 3 को count नहीं करेंगे, that is the repetition. For one period the signal is nothing but delta t minus 2 delta t minus 1. Okay. Okay, delta t minus 2 delta t minus 1. ठीक है जी, बढ़िया है, बढ़िया, fantastic it is. ठीक है. So if you want to sketch the signal, ये लीजिए. Somebody, suppose if you want the complete sketch of the signal, what is the signal going to contain, वो भी देख लीजिए. Okay, definitely number one thing जो यहाँ पे आ गया is the impulse, that is at origin. Then there is a impulse at 1.5, sorry that is wrongly written, वो correct कर देंगे. There will be a impulse, okay, with the area minus 2 at 1.5. Okay, then there will be a impulse again at t equal to 3 because of periodicity. Okay, then there will be a impulse again at this is origin and this has the area 1, this has the area that is minus 2, this is at 1.5, this is at 3, this is at 4.5, this will be minus 1.5, minus 3, etc 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 etc. ये टाइपो एरर था, 1.5 होगा, t minus 1.5 as we discussed here. Okay, so what is the signal xt? This is the signal xt. This is the signal xt. Correct. Nah, that goes for signals. Best beautiful questions will be found in OpenM, no doubt. Now k plus 2 is frequency shift only. Now k is a frequency parameter. K represents what? Okay, k is used to represent harmonics of the frequency. If you use k, it is k omega naught. If you use k plus 2, okay, if you use k plus 2, that means k plus 2 omega naught. Okay. If the integer is k, you get the frequencies as k omega naught. Okay, multiples of omega naught multiplied by k. Similarly, k plus 2 represent the frequency k plus 2 omega naught. So k omega naught plus 2 omega naught. Frequency shift na? K omega naught plus 2 omega naught. ठीक है. Definitely, Jashwant, definitely will plan, not this Sunday, but definitely very soon I'll plan the practice session on probability and distribution also. Very soon I'll go for it. Done hai ji? Chalo. This is done. These are very good questions. Okay guys, so yeah, the time is again approaching 11. As expected, again the session almost went for 2 hours. So if you want to enroll for the GATE crash course to have a fast track revision of your complete syllabus of GATE with the fast track theory revision and of course the lots of question variety, okay, through live classes, also recorded lectures available, study material, mock test, practice quizzes, everything available. You can enroll to the crash course. If you have any doubts, you can contact 924-133-666 and get any of your doubts, maybe with respect to fees or timing structure, etc. Yes. Now, first of all, okay, let me tell you the PDF of today's password. PDF of today's password. क्या रख दें? Okay. Today's PDF password, let it be frequency. I'll share you the PDF in my Telegram group. Okay, as always, it will be password protected. Only those who watch the session continuously, they get the password because you deserve it. Okay. So password is frequency, FREQUENCY, everything in small, frequency, everything in small, the word frequency. Now next session ki baat karen dear, as I told you, we are planning Monday, Wednesday and Friday. So next now will be definitely on Monday at the same time, timing no change, 9 p.m. and what we are discussing is the CTFT. Okay, the continuous time Fourier transform. Next, very actually more important in sense of question, Fourier transform. The continuous time Fourier transform. Monday, 9 p.m. Monday 9 p.m. After that, Wednesday, and etc. 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 That's it. Bye bye. Good night. Stay safe. Take care of yourself.